Welcome to Embedded FM. I'm Alicia White, here with Christopher White, and we're excited to have on the show the guy who wrote our favorite Unix command, Bob Cogshaw.
Hi, Bob. Good afternoon, morning, evening, whatever.
Hi, guys. How's it going?
Good. Could you tell us a bit about yourself?
Well, I guess I'm just another product of obsessive behavior involving taking things apart and wanting to know how they work. And that started when I was a kid. And slowly but surely, the ratio of things that I took apart and put back together again improved until I was employable. And then I went to college, and I professionally have been an embedded systems developer most of my career, but I've done a lot of other kinds of programming, and I've always kept one foot in the hardware world. And I'm internet famous for co-authoring that Unix command.
You can say what it is. It's all right.
Oh, sudo.
I always wanted to make sure you said it first because that is how I say it, but I've heard it said other ways.
Yeah, there's sudo, which I don't correct people. You know, it's all about being understood and not being persnickety about how to pronounce stuff, like my last name or VI. VI people, I've heard people call that Vi or six, as in
Six.
Roman.
Six. Oh, that's awesome. I'm adopting that.
No, I only use the 5 editor. They really screwed it up in 6.
Yeah. It all went to heck in a handbasket.
So,
anyway.
Yeah, you co-authored sudo, which I thought was really cool. It wasn't around when we did sysadmin in the 90s.
Was it? Yeah, maybe not.
I mean, we SU'd all the time, and I always wondered what I was going to RM-RF.
Well, that's because we had the power.
I know. It was so much power.
Yeah, well, it was making its way into distros in the latter half of the 80s and the early 90s. I don't know if there's a lot of different interesting aspects of it, but basically, in Unix in a nutshell, history in a nutshell is that it came out of Bell Labs and became accessible to people like me at colleges and around 78, 79 or so, and that was version 6. And quickly version 7 came out, and it was very, very austere. And you had LS, and I think actually you had dir, and then RM and MV and that sort of thing. But at any rate, that also at the same time, Digital Equipment came out with their VAX line, which was the big improvement was virtual memory, so you didn't have to partition everything anymore. And so Unix went to Berkeley, and Berkeley Unix was created, and by people like Bill Joy, who then started Sun, and I think he did the first version of the VI editor. But anyway, so now
editor.
What's that?
The 6 editor.
Yeah, the 6 editor. And actually, if you find the source code, he put haiku in the comments. That's just one thing I remember about sifting through the source code. But anyway, it was, of course, an open source distro, and we'd get it on MagTape, and colleges were buying VAXs and at the department level. And so I was hired as my first job to take care of the computer science department's VAX. And it's still, when Berkeley Unix arrived, 4.2 BSD, it still did not have, there was nothing like sudo. There was just SU. And so my job was computer technician. They had not invented the word sysadmin or network admin or desktop maintainer, help desk, any of that. It was just the guy who soldered the wires to the dumb terminals. And they, so that was primarily my job, was a hardware jockey. But I was supposed to learn as much as I could about the machine and administer it. And So I was there learning as fast as I could, but I still wasn't as good a software developer as some of my friends. And of course, I came from this cohort of people who had been going to school there. This is State University of New York at Buffalo at the same time, and we would all just kind of avail ourselves try to get access to these cool machines that had just arrived in exchange for tuition waivers or credit hours or both. And so I had, at any rate, gotten my first job taking care of the VAX, and I had my friend Cliff Spencer, who is the other co-author of it. He basically came in wanted access. He just said, "Come on, Bob, give me access to the computer science department VAX." And so he started, just poring over it, and he had been writing in Forth and 8086 assembly language, and he basically got to the point where, "Bob, give me something to do. Give me, tell me something that you need that I should write." And I'm like, "Well, the CS professors, they keep asking me for the root password, and I'm not going to give it to them. And so what we really need is a command that'll dole it out on a per command basis. And oh, by the way, I think if you set if a root owned file, the set UID bit of a root owned file of a shell, you'll get a root shell. So we want something like that, but not that lame."
So we've skipped over something important here. You keep saying VAX, and VAXs are supposed to run VMS. Did you just kick that to the curb?
Yeah. Well, heck yeah. So it
was a fine operating system once you figured out. I never figured it out.
Yeah. I mean, before that, of course, there was a PDP-11, and we ran RT-11 on the little ones and RSX-11 on the big ones. But always, I was the outlier who came in with these tapes, and I said, "I want to load this other operating system while you aren't using it. I'll come in at night and I'll run it." And this is the clandestine running of the Unix. I would come in and run it and for several hours and play with it, and then I would unload it, and then I would reboot machines, and then into RSX or VMS or something awful, and go home. And I was working at a monkey lab. They did research on monkeys, and they would actually put little probes in their brains, and
so you put BSD on them?
Yeah, I had a Kim 1 I was supposed to actually wire up to a feeder, and they were supposed to focus on a light on a blank screen, and that would allow the scientists to get a baseline of their visual cortex. And so I was...
Wait a minute. That is so cool, because I'm working with mice that have little probes in their brains. Where I'm working with it's happening in Maryland, and I'm in California and have nothing to do with actual mice, but it's still really cool.
Yeah, well, it's fun to have a monkey just kind of walk down the hall in front of your office door and have its own. I mean, they were very nonchalant about the monkeys were like, "Okay, I'm going to go into the lab now. I'm going to sit there and." When I press this little button, because I've been fixated on the LED properly, I'll get a treat. And so I was writing the code for the Kim 1 to give them the treat. But anyway, I was banished from running Unix on that machine because one morning they came in and it wouldn't boot. And of course, you call the field service tech, and they came out and they replaced a core memory board. And that was it. And then we ran Unix again, and the same thing happened. Core memory. Now that could have been a coincidence, or it could have been actually Unix was running a very tight loop and burned up a location in the core memory. We don't know. But PDPs, I was always the one who would not run the DEC OS from a very early time, unless coerced.
We were getting to why did you need sudo? I mean, you didn't want the professors to have the password, which I totally remember from my sysadmin days in the computer science department. And you worked with Cliff to get it written. And then, I mean, I've written a few programs for my local system. Where did it go from there? How did it end up ubiquitous?
Well, so this is the prehistoric days now, and the only thing we have hooked up is Usenet. So this was modems and software, and the VAXs and other types of machines, but mostly VAXs running Berkeley, would call up each other at night and exchange news articles, net news. And it was sort of like a sponge where, if an article would basically try to go everywhere and get a copy of itself on every machine, and until everyone had the news article. So there were special news groups for publishing source, comp.sources.unix. So after a couple of years, we spread it around, to our buddies on campus, and Cliff went on to other things. I went on to other things, and other people became the custodians of it, and they published it by just putting it out on comp.sources.unix, and copies went everywhere, and people started using it on their VAXs running Berkeley, and also there was other things like Pyramid 90Xs, mainframes, just before mainframes died.
Well, it makes so much more sense because you go from having a power that you log into, you become super user, to having an atomic thing that happens as super user.
Yes, and of course people cheat by just giving themselves a root shell, say sudo bash or sudo su. We've all done that. Sometimes it's prescriptive to do that, and I don't personally have a problem with it. But the philosophy around it has been, at least at the core, has been kept the same. The original idea was to have it be able to dole it out on a per user basis, know who was using it, and have them use it on a per command basis. And at least, even if they were just going to just do a sudo su, it would be in the logs. Hopefully they didn't immediately go to the logs and erase them.
Which is an option, but... So I've had one of my products mocked on The Simpsons, and Christopher recently had one of the brother products to the thing he worked on mocked on The Big Bang Theory. You've been mocked in XKCD. How was that?
Again, that was like a total honor to be have something we created become kind of part of tech culture to the point where it's in a cartoon and everybody knows sudo make me a sandwich, what that means. And I don't know. I think that I would be very happy to send Randall Monroe a signed copy of the sudo man page, but I think if I would be getting a much better deal by getting a signed copy of that cartoon. Hint, hint.
And Randall, if you're listening, you're welcome to come on the show anytime. So,
more likely, if anyone knows someone who knows someone who knows someone who knows Randall, suggest it to him.
This is like that movie where they tried to date that movie star.
What?
The Molly Ringwald movie star.
Nope.
No.
The End Degrees of Kevin Bacon? Or?
Wow.
I don't know.
No.
We'll cut this out.
Really? Because this is the high point, man. We watched the movie. It was a documentary. It was very silly.
A documentary.
It was Drew Barrymore. He was trying to get a date with Drew Barrymore, and Yeah. Some people out there are like, this is a stupid conversation. The other people are like, it's this movie. And I'm no. Okay. Well, let's go on. So having done Sudo, how much did it help you in your future career? Or was it always something that happened and now I want to have a real job?
No one knew. It's only in the recent couple of years that anybody actually cared or asked, and I actually don't bring it up unless I'm asked, and I put it, down under professional accomplishments. It's one of them now, but there's patents and there's decades of writing code, and so it basically I haven't been offered a free drink or anything in bars, or look, here comes Bob Coggeshall. Everybody run. None of that.
Still waiting for the ticker tape parade, huh?
Yeah, no, and it's just you don't know. We just didn't know that it was going to have any. It was going to make it into distributions, and everybody was going to use it. And so, here's other ideas for podcast guests. Some of the old Bell Labs people, before they actually are gone, would be awesome to talk to, like Aho, Weinberger, Kernahan, the Auk fame.
Yeah.
But anyway, that's just I don't know.
Yeah, it's one of those things. It's fun to talk about and doesn't really buy you that much.
You mean being the author of something like that?
Yeah.
Not working at Bell Labs.
No, that's different. No.
That's different.
Yes, sorry. I thought I was clear.
I got up so early this morning. We'll see. Okay. So, but this is not what you do now. You do something entirely different from writing Linux commands or Unix commands. What are you up to?
Well, a little while ago, I was looking at this whole maker movement thing, and I was having a lot of fun doing my own projects, the Nixie tube clocks, and my day jobs often involved microcontrollers, and I would just come home and keep working on microcontrollers. So that was the funnest one of the funnest kinds of programming that I've been able to do, and I've always done it whether I was getting paid to or not. And so once the maker movement kind of started to define itself, I started to think to myself, well, maybe if there's a way to actually make an honest living out of the maker movement, how to monetize the maker movement. That was my thought.
It's a very honest sentiment.
I just didn't want to go work for the man again, as just preferably work for myself. And most people kind of would prefer to do that, I think. And so I was looking at the different businesses that were being created, and kind of quickly came to the conclusion that the big winners were like the winners of during the Yukon Gold Rush. So Seattle really grew rapidly during the Yukon Gold Rush. And it was because they put down a law that said you can't come into Canada unless you have so many months worth of supplies, because people, really was like environmentally hazardous. You couldn't go up there and people were just going up there any way they can to, stake a claim. So it was the retailers who were selling the boots and the blankets and the pickaxes to the gold rushers that really were making the money. And so the analogy in the maker movement is it's the widget builders and distributors like the Adafruits and the Spark Funds of the world. Maker Shed is more of a pure reseller of stuff, and Adafruit kind of do it in combination of building their own stuff and reselling stuff. And I thought, well, they've got that all sewn up. Besides, that's not that interesting. The building part is interesting. The reselling stuff isn't that interesting. And so I was, of course, building these Nixie tube clocks and had moved to surface mount and learned how to become as efficient as possible doing them by hand, but still building them really wasn't that interesting and prone to error and takes a lot of time. So, of course, I yearned for a pick and place machine. So
doesn't everybody?
Yeah, it is one of those classic nerd lusts machine to have.
Glowforge laser cutter, 3D printer.
Check.
And pick and place machine.
Check.
And a mill.
And the other mill. Yeah.
Yeah.
I don't know where I'd put that on the priority list, but it would be high.
Yeah. So I started thinking to myself, well, and I also had built, had some boards built by traditional contract manufacturers, and at this point, kind of it congealed in my head. I had this epiphany, and this, there's always this fatal step in any project, and it starts with how hard could it be? And so I said to myself,
that's always a dangerous question.
Yes. That's almost worth it. Hey, watch this.
Yes.
How hard could it be to start a low volume electronics assembly business for people just like me? Because there were all these widget makers out there that were evident on Hackaday and then later on Tindy, and then all these other places. And they, I just kind of embarked on this mental exercise initially, and decided that, okay, I think I want to do this. And so I went to my wife and said, hey, can I, peel off a few bucks from the savings account? And she's like, what? You want to spend $50,000 on? Write a business plan. And,
yeah, there's the amount of money you can spend without asking your spouse. Then there's the amount of money you can spend without your spouse flipping out. And then there's the amount of money where your spouse is like, no, honey, this is bad.
Exactly. But my spouse is a perfect foil, and she complements my shortcomings perfectly. So that the write a business plan order was a direct manifestation of that. So and it was a good exercise to do. You sit down and you look at who's your market and what do you intend to do, and what are the risks, and blah blah blah. And so I succeeded in getting the approvals, and so then I bought a pick and place machine in January 2013, I think. Mancorp MC400, also known as the Autotronic BS281 in outside of North America. I think that Mancorp said, we are not selling a product that starts with a BS. So it's called the MC400 by Mancorp, but Mancorp doesn't make it. They resell it, but they support it in North America and also South America, I believe. So at any rate, so I basically got the machine, learned its care and feeding and what it needed as far as how to fit it into a workflow, and then I embarked on writing a website to automate and make it as easy as possible for people to submit their jobs and ask as few as questions as possible. And Oshpark at this point was a very big influence, and I knew Lane, and I was looking at his website and talking to him, and now what he does and what I do are pretty different from the implementation standpoint, but philosophically, I think the whole venture shares a lot with Oshpark, and they do send me lots of customers. So
well, yes, because once you make a board at Oshpark, your next question is, how do I get this stuffed?
Right. So at any rate, I basically, and this is kind of a thing that we might go into a little bit, is about, in your career, when you're, there's this 5,000 hour rule that they say, if you want to be an expert, you got to at least do 5,000 hours of whatever that is. And I think programming is similar to that. A couple of years into actually writing code professionally, you're going to get good at whatever that is. But after 10 or 20, 25 years, you are going to write in a lot of different languages. And so that was true for my career. And it went from, punch cards in Fortran and then C and C++. And then there was Perl but I didn't know to write this website. I said, well, I gotta pick a language and an approach. And I looked at Python and looked at using Django, the Python framework, and chunks of it are written in Python, and I did teach myself Python, but I just decided that was not the right approach. I wanted something that when I Google my problem, I want 10 answers on Stack Overflow to show up. And if I had done that with Django, it wouldn't have been, not as many people would be out there with the same problem. So I chose PHP, the language people.
I'm sorry.
Love to hate. Yeah, they and I knew I'd get guff from people about that. But really, and it's fun to be a snob about languages. Like, for instance, I loathe jQuery, and I think if JavaScript is the alien, then jQuery is the head burster, and it shouldn't I only learned it because I had to get certain behaviors out of the browser. But now, of course, there's things like Node, and everybody's running around, and then there's embedded targets that will run JavaScript, and I have to get off, my snob throne and say, really, you know what? It's just another block structured language, loosely typed, and it, all the languages are at least 80% similar, and once you've written in 2 or 3 or 4 of them, then the next one really isn't that big a deal. So at any rate, that's what it's written. Sorry. And it's a bunch of WordPress plugins because WordPress was just out there, and that gave me 90% of my solution for a framework. And so, so that's someday when I can afford it, I'll foist that off on some poor undeserving person.
So you're looking for an intern already?
Yeah.
But I think that the interesting thing is that you built an entire business with a lot of disparate elements by yourself, from the website, the marketing side, the actual physical assembly side.
Interfacing to that Mancorp MC400 is not going to be a trivial, let's just bang this up with PHP.
So I kind of want to know how long it took you to go from I bought the machine to I'm taking orders. And did you plan for that, or did you just sort of, okay, I have this, now I have to do this. Okay, now I have this. How did that work?
I had, of course, I'm no better than anybody else in estimating how long it takes to write code. And so it was probably 9 or 10 months before I first got the machine to when I went off and wrote all the support code and the workflow and came back to the machine and said, okay, this, and I had inquiries. Lane was sending me people that wanted this to try the service. And so, it was 9 to 10 to 11 months. There were, it trailed off, make the final tweaks. Oh, and the pick and place machine runs Windows XP, and the whole code, all the software is written in Microsoft Visual C++ version 6.
I'm crying.
And and it's all written using the Visual Fox Pro DBMS.
Oh my God!
I was okay until that.
Actually, that I mean, it's the most secure computer on the planet, probably.
Yeah, right. So
nobody's bothering to attack any of that.
No, it's pretty. So the software has not been refactored. These machines have been versions of these machines have been coming out for at least 15 years, and so they've just added incrementally and said, okay, well, we're not going to use laser machine-based alignment. We're going to use machine vision with a little camera, and so we're going to add that, and we're going to add more, make the feeders faster or things like that, or it's going to be closed loop, and we're going to use make the machine more accurate. But all those were incremental changes. So, it's pretty awful. But if you look, like I went to SparkFun for a visit and saw their manufacturing, and their $300,000 pick and place machine is running this thing that software, just the sophistication level of the screens is nothing more fancy than you would find on a DOS machine. It's just very much terminal curses, single font. So
yeah, that's not its job.
Yeah,
that part works. Okay, we're done with that.
Yep.
It does seem to me like that's another area that is ripe for somebody to come in and do, a low-cost laser cutter / low-cost 3D printer style disruption. I don't.
Yes. So there are a number of different desktop pick and place initiatives. When you go to any maker fair, you see 2 or 3 or 4. And there is one person, I think they're in Seattle, I forget the name of their project, but they had a very nice, brand new, written from scratch user interface to their pick and place machine. And I kind of just wish that they would go take one of the Chinese machines that are not coming out with machine vision, and just you got chocolate, my peanut butter. Put their software on those Chinese ones, which are getting more and more solid, and so that's my prediction of what'll happen. I'll be out of a job.
Well, there'll be a different job then. I did note that, as with Lane of Osh Park, as you're doing very hardware things, your job is software. Are you a hardware guy doing software? Are you a software guy who is helping build hardware? Which way do you see yourself?
Well, right now I'm a hardware assembler. Now is what I've kind of reduced myself to. But the world historically has employed me as a software guy that has some knowledge of hardware. It was really the whole summation of that. So if you were, but I continuously do my own designs, and I now I have a pick and place machine and I can build them. And maybe that was the secret agenda all along, doing small batches, just having a way to build my own designs. But it really is now. I'm a service provider. There's not much for the software. There's lots of improvements to do on the small batch website, and I need to get back to them. But all in all, really, my day job is now, getting parts in the mail from people and putting them in the machine and putting paste on the boards and picking them, placing them, putting them in the reflow oven and setting them back. So
you said small batch, and I'm not sure you've said the name of your company yet.
Oh, Small Batch Assembly.
Okay. And that's smallbatchassembly.com. And so how is what you do different than a contract manufacturer?
Well, I am a boutique, I guess. I'm a contract manufacturer boutique. Contract manufacturers do assembly services, and my spin on it is to do it at a more of well, first of all, make a better, take a better stab at the customer relationship and to automate the job submission, because regular traditional contract manufacturers just work with zips over email, and people look at it and kind of eyeball it and say, yeah, okay, we can do that, and we can do it for this much, and then send back a quote. And it was kind of I wanted to I wanted to take a better stab at it and improve that and automate that, and hopefully pass on some of the efficiencies that were realized, reflect that back in what I charge the customer. That was sort of the whole goal.
And focusing on the maker market means you're okay with building 5 boards. You don't have a minimum order quantity of 100, which some of the CMs, they don't really want to talk to you unless you're building a lot of these.
No, the old model, that's correct. The old model, their model is, what you building? And you're, of course, going to build 1,000 of them, right? And a month, right? And so just send me your zips, and we will just figure out what we need to do to work together. And that's the level of automation, pretty much.
They're looking for an ongoing relationship, bread and butter every month.
Right. And so they will basically eat their NREs, their non-recurring engineering costs, in their pre-sales with you while you're doing your prototype in low volume, in exchange for the knowledge that they're going to get the volume business. But now we're in this world where there is no volume business for a lot of small niche markets. The Tindies of the builders of the world, for instance, they typically have day jobs and other income, and they're doing this, building their little boards because they just can't turn their brains off, like all of us, and they are just looking to build a residual income, doing these little businesses on the side, and they may grow. And hopefully, my best customers are the ones that I have to fire because my pick and place machine isn't big enough to handle. They're fast enough to handle the volumes they're doing.
It does seem like you could be taken over by a single customer quite easily.
It is. And there was in the couple of years that I've been doing this, now I see a couple of different classes of customers, and the maker ones are the Tindy types are the largest, but there are those that are local, like some labs that just say, "Oh, hey, I'm in Virginia too, and just can I come over and just deliver the parts to you, and and see your pick and place machine and chat with you, and so there's this kind of local high touch kind of a customer that is fine too. That's great. And CMs are everywhere too. Any major city is going to have, even if it's not the Valley, is going to have a number of contract manufacturers but they're going to be of this larger variety. There's a couple that try to do high mix, low volume, which is what you call this style of contract manufacturing.
And so how do people, so if I want to make a board and I send a board off and I get it done at Osh Park and I build a couple and I realize this really was what I wanted, but hand soldering them is beyond me, or I just had somebody ask me for a couple for themselves and I decided I want to make 20 so that I don't have to hand build them anymore. What do I do? I mean, right now what I would do is stare at them and then wait for people to go away. But with what you do, what should my next step be?
Well, so you've got some boards that you've put together and gotten to work, right?
Yeah.
Okay. And so you would just basically go look, get some more boards. You're happy with your design. There's no cut traces or jumpers anymore. And you look at your bill of materials, look at how much they cost, think about how many you want to make, can afford to make, should make, and that might be a very low number. Still, 25 is not unusual. But as you go up in number, then the unit cost goes down. And so you can, your next step would be to, after that, figuring out what your volume, how big a run you want to do. If you want to use my service, you would go onto the website and there's a pricing engine. You don't even have to interact with me. It'll just give you the prices for assembly for your, if you key in the number of placements you have and the number of unique part types you have, and then how many boards you want. That's pretty much all I need, all the Python script needs to give you back a price. And then you decide, well, okay, this is the assembly cost and this is my BOM cost. Is my quantity still right? Do I want to build more? Do I want to build less? The price goes down if I build more. Unit cost. You iterate a little on that, and then you, if you want to go forward with it, you would then submit your CAD files. My system requires two files basically, a CSV, which is sometimes called the placement bill of materials, or the XYRS, or the Centroid file. Basically, it's one row per placement, and each field is going to have the reference designator for that part, R1, R2, C1, Q1. Then it's going to have manufacturer part number, and then X and Y coordinate in inches, and then rotation in degrees. And that's it. And that file that is generated by most EDA tools.
So KiCad or Eagle or LTM or whatever I have. Correct.
So you would then there'd be specific instructions, like Dan at Rheingold Heavy has instructions for KiCad, and I've got instructions for Eagle. Or you can just read my FAQ and figure out how to do it with your EDA tool. And then the only other file I need is the paste layer, the Gerber paste layer, which gives me a picture of the layout of the board and allows me to create the stencil to apply the paste to your boards.
So you mentioned a Python script that does pricing. That is fascinating to me because that sounds like something that would take a lot of iteration to get right.
Well, it served a dual purpose. So during the write the business plan stage, there was a lot of looking at pricing, and and I was also in parallel basically saying goodbye to Perl, which I had used as my glue language for many, many years, and committing to learning Python. So it really, the pricing, the job of pricing really is to plug in, know how long it takes to perform each step of the process, and what your labor rates are. And so when the customer inputs the number of placements and the number of items, that can get computed. So it's just really a bunch of tables. The BOM size is the number one thing which affects assembly cost when you're doing low volume. So if you have like 10 different kinds of parts, it's going to cost less to build, to assemble, and take less time, because than it would be for 30 parts, 30 unique part types. The pricing is less sensitive with respect to placements, because really all the time is labor, and time is in dealing with each part type, making sure it's the right one, barcoding it, getting it onto a feeder, mounting it on the machine, teaching the machines machine vision about the part, doing a test pick to make sure it's right. So, and that can be for a part that's strange, it could be up to 10 or 15 minutes per part. If it's just a 0603 resistor, it's usually about 7 minutes or so, somewhere around in there. So at any rate, that's the key kind of price drivers in doing an assembly service.
And you have some parts in stock.
Yeah, I do, but that's kind of I don't want to say I call it a failed experiment. It's kind of just an out there thing that is probably going to change. So when I started, there was no such thing as common parts library. And I was just...
Okay, what is the common parts library?
Yes, common parts library was created by Octopart, and there's a consortium of people like Adafruit and SparkFun and Small Batch Assembly and a bunch of others that have that support it, and it is just a sub list out of the millions of parts, electronic components out there. They've said, okay, here is the most common set, and so if you Google common parts library, you should get that Octopart thing. So they basically is kind of put a stake in the ground and said, okay, these if we all use these parts, and it'll simplify matters. And so I had created my list before Common Parts Library, and I have since improved the site by using Octopart's RESTful API to look up and fill in information for parts. So that's why I only need the manufacturer part number anymore. I used to ask for a lot more information. My goal is to ask as few questions as possible to the user of the service. And so my parts library really is just, it's there. You can use it, but it is, I don't stock those parts. And if someone, say, wants to, order them 75 at Mega 328s, I might have a reel of, 150 at Mega 328s. Or I might decide, I will go ahead and buy a reel and pass the savings on to that customer. But in the future, it's probably going to be EOL'd. My little list is going to go away, and it's just going to be the common parts library list.
That makes sense. Although that brings up the other part. When I have made a small batch of boards, kitting is one of the hardest things. I think that is an area where people are going to be like, oh, how do I do this?
Yeah, they do. The rest of my workflow would be once you've entered the CAD and submitted it, then I send a price back, and then you pay on PayPal, and then I would send you a kit, some PDFs of labels. And this isn't uncommon. This is not uncommon. And the way people attack it is usually sometimes they will just submit their BOM to a distributor like Newark or Mauser or DigiKey, and those distributors have tools which will just take your BOM all in one go, and then create an order for you, and you will get a list of you'll get the parts all kitted up for you by your distributor, so you don't have to worry about it.
If you manage to find them all at one distributor, which never happens for me.
No, and that's true. In practice, you will end up with a bunch of little plastic bags full of parts that you're going to have to sort through, and that is just one of those chores that you have to get through. And there's lots of efficiencies that you can apply around it. But I'm right now I don't offer. Some people will just send me the stuff, and if they ask me, I say, "Okay, can I just send the parts from DigiKey to you?" And I'm like, "Yeah, sure, that's fine. Drop ship. Yeah, I'll they can do that."
How is running this small business different from your years of consulting? Is it better? Is it worse? More lucrative? More fun?
Well, it's more fun to be able to just directly run something that you've created from scratch. There's a lot of gratification in that. Now, on the other hand, it's a small business, so I'm chief bottle washer and everything else. So it is. I think the fun outweighs any disadvantages there are. It is, you do have to have the flexibility to work when if there's a lot of orders coming in. You have to work a lot of hours. If there's not a lot of orders, and you don't have to work a lot of hours. In consulting, the relationship also is usually for a longer period. An engagement. The software engagements, software consulting engagements might be, a few months, or a bigger
crunch times with the consulting. They happen, but I imagine they aren't as crunchy. They aren't as hard as they are with orders, because you don't know if a giant order is coming in until it comes in.
No, and also my orders are, I restrict myself to low volume just by virtue of the fact of my machinery isn't that big and fast. So there is an upper bound to the size of a job. So no job is going to take me more than on the calendar a week to get in and out of the shop. That would be a big job. That'd be thousands of boards for me. Everything is smaller than that. Typically, I'll spend on the calendar maybe 4 business days working on a job, and so the relationship is with the customers. There's many more of them, and the engagement period is much shorter.
Lane mentioned his boards are colored purple, so he could see them in projects. He could walk by and say, "Oh, they must have used my service." Do you have an identifier? Are you giving out stickers or somehow making a mark so that you can see when?
Oh, I ask people if they will, if it's okay to tweet their boards, pictures of their boards, but sometimes they prefer not to. Sometimes they're completely proprietary, and I can't. And so I try to do that. And I can only spot them sometimes. I did a huge number of LED boards for the R2, what do they call it? Astromech.net people. And they buy and sell parts to each other to make astromechs, anatomically correct, life size, make noise, bleep and bloop. And so I made an LED board for R2D2s for one of these people who resell them to their buddies making other R2D2s. So whenever I go to a maker fair, I will hunt down the R2D2s, and I will look into their little LED sensors and try to determine whether my board's in there or not.
Gaze into the eyes of R2D2. No.
He's only got one eye, I think. Well, he's got that little one down there.
Yeah. And then also there's one guy who does that has a board that SparkFun resells. So a board that I build is in SparkFun. SparkFun doesn't build it themselves because it's not a high volume thing. They just order from him, and I build them for him. And then, so they're that. So I don't have any really systematic way of knowing where all these boards go unless somebody contacts me later.
You need to put special parts on them, secret little resistors.
Yeah.
Oh, yeah. Specially colored resistors. That would be cool.
It would, or I'd like to do one in patterns. There's nothing that says you can't lay down, your layout has to be all rectilinear. You could sort of, perturb all the layout like a wave or something, like maybe it looked like that whoever was designing the board was drunk.
I saw a board like that recently where they did all curves for the lines. It was cool.
Boldport does it. If you look up Boldport on the interwebs, he's the guy who does the boards that are just beautiful, art, curvy traces.
Neat. So let's go on to a couple of other questions. You mentioned Nixie tubes, and I know you've done a lot of work with them, a lot of kits. But before we jump into those, can you describe a Nixie tube as though I'd never seen one?
Well, a Nixie tube is a device for displaying information, typically, most commonly, the numbers 0 through 9 in each tube. And it was in the heyday of the 60s. This was, in fact, the best and only way to indicate numbers on displays. It was before 7-segment displays, before semiconductors. And it consists of a glass enclosure with a number of metallic elements inside. And the enclosure is evacuated, air is removed, and a little bit of neon is put in there. And sometimes a little trace amount of other stuff, of gases. And then the behavior, when you pass electricity through the wires that are adjacent to each other, they will glow. Where the electrons are coming off if you apply negative on one piece of metal and positive on the other, the negative one, the cathode, will glow orange. And people think it's very pretty. And so Nixie tubes are, each little piece of metal is shaped like a discrete digit, and it has a wire, its own wire coming out the bottom or the end. And so you're going to have 10 little wires. Each one is a digit, 0 through 9. And then you're going to have another one, which is usually going to be grid, like a screen. It's going to be in the front. So when you look at the tube, you're going to see the numbers stacked. You're going to see this grid, and then you're going to see the numbers stacked. And so now you can, with proper drive circuitry, you can then light up any individual number and indicate any individual digit. So a display would consist of a number of these Nixie tubes, and then you could, have as many as you need to display whatever you want. So lots of people make clocks, so you need 4 typically for hours and minutes. I make one with 7, so I have hours, minutes, seconds, and tenths of seconds. I went on to design a driver board that can drive up to 8, and really is has a variety. It separates the tube board from the driver board. So my driver board can drive a variety of different types of Nixie tubes. Nixie tubes are no longer made. It's just new old stock. And they are, the price has been going up steadily, but not exponentially. Some of the rare ones, some of the larger ones will go for many hundreds of dollars each. But there's still lots of ones out. If you go and just go on eBay and type Nixie, N-I-X-I-E, you'll see tons and tons of smaller ones that, many of them come from the former Soviet Union.
Yeah, like all vacuum tubes.
Right.
Yeah, I wonder if when the price gets high enough that somebody will start manufacturing them again.
Yeah, that's a very commonly posed question, and they do build vacuum tubes now again. But so far, no one has announced that they're going to be building Nixie tubes again.
Now, you can't just hook these up to the logic outputs of your microcontroller and away you go. These are difficult to drive.
No, it's just a higher voltage. Yeah. That's all. So you need some drive circuitry. So basically, it's typically done. You find a source of the voltage that neon ionizes at, which is 170 volts.
That's a little higher than 3.3.
Yeah, and so you don't want to hook that up directly. So you get a supply, 170 volts supply, and those are also available on eBay. And you run it through a typically a P-channel MOSFET, a little transistor or FET, which has been rated at 250 volts. And then the gate is where you attach your microcontroller. So the microcontroller can now just wiggle the signal at microcontroller levels, 0 to 2.5 volts, and then the FET will do the job of switching the high voltage on and off. So it's that's how you do it.
Okay. Why? I mean,
why?
They're cool looking.
Why not?
Yeah, why not? So many of these things that people do, it's just kind of a why not sort of thing. My story was that I was just got interested in them, and I discovered eBay. So eBay became kind of this opiate of reliving, buying old junk from my, that I hadn't been first became acquainted with as a kid, and Nixie tubes were one of them. And so I just kind of started buying Nixie tubes, and then of course you're confronted with, how do I activate it? So then I started perfecting high voltage drivers, and then the whole controller board thing, and that really just started out as a something to entertain myself, and so that's kind of how it's got started. And now it's gone on through, it started pre-Arduino days. So I was using a PIC back then. And when Arduino started becoming popular, I thought, okay, well, I'm an embedded developer for a living. And so I need to check out this Atmega 328 thing and see. It would be probably cool if I made a Nixie tube clock driver board, which people could then use and modify the code via the Arduino IDE. Although I personally loathe the Arduino IDE, but I found ways to just not conform with it. You stick your stuff down in the libraries in a file directory called libraries, and then you can just sit there in your choice of editors, and then just hit build in the IDE, and it will take care of compiling it and downloading it with AVR Dude.
Oh yeah, but there are many ways to avoid that IDE, which is not pretty.
Now there are other things that are happening. I'm kind of we could segue off into, but that's probably under like future things. So I don't know. I don't want to deviate from your script there.
Oh well, I have no idea where we are in our script, so it's fine.
Okay. Well, so while we're talking about that, I kind of was looking for a new microcontroller to start using, because 328s are, I'm out of flash, basically. 32K isn't cutting it, and the software, the whole software itself, just kind of if-deft beyond reason to have it all fit for all the different versions of tubes. And so I've been looking at the new Atmel Cortex M0s. I'm not a shill for Atmel. I just am looking at them objectively. And it did help that they were kind of just giving these away like candy at the last Hackaday event I went to. So they, what are they called? The Atmel explained letter X planed boards. So I'm looking at the Atmel D20, which is the Cortex M0, and the ID
super low power.
Yeah, and
the D20.
And Arduino has their 0, which is based on it, and they're taking a little bit of a different spin in that they put the debugging hardware on the board, and your target, of course, is not going to have it, but the 0, Arduino 0, and the Explorer explained D20 has it on there. And I was thinking, what are they doing this for? But it now makes sense that, the people really like to have, source level debuggers and be able to set breakpoints. And I have to admit that comes in handy. So that is why they did that. And now I'm looking at the Atmega Studio 7, the latest piece, their IDE, which is based on Microsoft Studio, and they're giving that away for free. So the price is right. So I'm giving that a shot for future designs.
Cool. I think that also is supported by the Mbed Online compiler, which is good and bad. It doesn't have source level debugging, but it does mean that if you ever need to run a class with a whole bunch of them, you don't have to deal with everyone's computers. It's all online. You do have to deal with everybody's computers not getting to the internet. That's a separate issue.
Yeah, more and more stuff is like that.
So speaking of classes, wasn't that like a seamless transition until I started talking about it being a seamless transition? You do teach some classes.
Yes, so I'm co-located with the Nova Labs Makerspace in Reston, Virginia. And the way I contribute is to hold classes. And I do recent ones. I've done our surface mount assembly. So I take people in, and in about 2.5 hours, they walk out with a completely assembled little display board. And the goal there is to make people completely unafraid of surface mount, because that's kind of now a prerequisite to working with stuff if you're ever going to design your own circuit boards, and if you're ever going to do them in any volume. It's going to be surface mount. So that's one. And then I have an Eagle CAD class, and that's kind of uses the same boards. And these boards are all at-tiny 85 based. And in that class, it's again a 3-hour class, and it basically people come in with Eagle running on their laptops, and then I give them a bag of parts, like in the surface mount class, but they're through hull, just not to freak them out. And then they design their own. We all sit there and step through, and we design the same little tiny circuit, which blinks 2 LEDs, and it's hooked up to a battery. And it's going to be another one that's going to be Eagle 102, which is going to be the surface mount, a surface mount version of the same thing. And we'll get into designing libraries, parts, pad designs, land patterns for parts, because that's kind of an intermediate task everyone needs to master in any CAD design. And I teach Eagle because I know it. I catch a lot of guff from people for not using KiCad.
It's not online. It's not free. It's not open source. It's not. It's actually quite functional. So I can see why you would do it.
It's just you got to go what you know, and you have so many hours in the day to teach yourself new stuff. And maybe down the road I will start using KiCad and start teaching it.
Well, I am about to wrap up. Christopher, do you have any questions? No.
Why am I always stumped on this?
I don't know. I mean, we didn't get very far through our outline, so there are plenty there. I'm just, I just realized it's lunchtime, and my brain sugar went like,
your brain sugar.
You have no sugar in your brain, and now you're toast. Caffeine is not enough.
The brain sugar.
Brain sugar, baby.
You
look, I'll ask another question.
Okay.
We'll pretend like we're professional or something.
Yeah. We're all over this.
So we've talked about makers, and we've talked about your engineering career. What do you see as the difference between a maker and an engineer?
Well, makers, many engineers are makers, and many off the street people are makers. So it's people who I think see the commonality as people who want to learn. They are self-motivating in that they want to know more about all these different technologically driven skills and learning the tools, and it may be a rebellion against everything becoming all shrink wrapped and nothing's repairable anymore. So an engineer is really a professional maker that's been doing a specialty for many, many years, or at least has that aspiration when they're starting out to do the same kind of thing. So makers can just be anybody, all you have to do is come with a positive attitude and want to learn. That's kind of the fun thing of hanging around makerspaces, because everybody is kind of that open-minded ilk.
Fair enough.
All right, I thought of something.
Okay.
So you're in Virginia.
Mm-hmm.
Well, it's not considered the epicenter of technology, is it? Or is there a big community there? I have a follow-on question. So.
Oh, well, in fact, I thought the same thing when I moved here in 2008. I didn't know anybody, and the economy was kind of like a little tanking. And I quickly found that, the jobs that were out there, you needed your clearance. And so I kind of went through this funk of not knowing anybody. And then once a couple of years elapsed and things like Meetup got created and the Nova Labs Makerspace got created, there's now like no problem. It's very evident that there's lots and lots of people doing techie stuff, and and the Beltway is full of people doing all kinds of different sorts of software. A lot of it's security related. A lot of people, members of the Makerspace, are doing security related stuff. That, when you go to a dinner party here, you kind of just don't walk up and say, "So, what do you do?" And you don't. You might be able to ask that, but basically you'll get a.
What's your clearance?
I work for the agency.
Yeah, right. Yeah. Which agency?
Yeah.
Best you not know.
Do you feel like things have? I mean, it's kind of obvious that things have changed, but it used to be that if you wanted to work in tech, you were either in the Valley or perhaps in Seattle. And now you can run a business like Small Batch Assembly and be pretty much anywhere because of just the internet and the way we communicate now. I mean, people don't even probably know where you are necessarily.
Yeah,
until they get a box, right?
Yeah, that's true. Absolutely. I mean, it's I think that it's nice that we're kind of within a few time zones of each other. But really, the internet and UPS and FedEx and even DHL internationally is basically commoditized this to make working with physical stuff pretty easy, and so it is really less and less important where you are. So, like all the Hackaday people live, for instance, they don't even. I don't think any of them live in the same state, but they all run Hackaday, and they get together physically sometimes. But for the most part, they're all over the place.
Yeah.
So, no problem.
Well, Bob, do you have any last thoughts you'd like to leave us with?
Oh, I don't know. Follow your passion. If you're basically not you got to figure out what you're good at and what you like doing, and it's okay to change your mind. It's okay to take a really long time. Sometimes I think I'm still trying to figure that out. Do a wide variety of things. Take little tastes of experiences from all sorts of things, and don't settle down too early. Don't get yourself all encumbered with responsibility, and be kind. It doesn't cost a damn thing.
I appreciate those words of wisdom, all of them. Those are great. You also had a coupon for listeners of Embedded FM if they were going to try out the Small Batch Assembly. Do you want to tell us about it?
Oh, yes. Very simple. Mention that you are a big fan and you listen to all the Embedded FM podcasts, and you sat patiently through this one to hear that you'll get a 20% discount on your order.
On your first order.
Assembly. On your first order. Yeah, on your first order.
Cool.
And so just go to the, it'll be in the show notes, right?
Oh, I wasn't good. No. They have to listen.
Oh, smallbatchassembly.com. Yeah, you can.
Oh, no. The website will be in the show notes. Yes. Okay. Yes, of course. The coupon will only be here.
Oh, yeah. Okay. That's cool. Yeah, because I guess the websites live forever, and they'll read that in 3 years. Like, oh, where's my discount?
You can turn it off.
and we have the power, the editor.
All right. Maybe I'll mention that there might be a discount at the end of the show.
That's probably better.
All right. Okay. We have a plan.
Just do sudo vi the PHP.
My guest has been Bob Coggeshall of Small Batch Assembly. The coupon is that you mention Embedded FM and get a 20% discount on your first order with Small Batch Assembly. So it's even cheaper to try out. The website is www.smallbatchassembly.com. And thank you so much for being on the show, Bob.
Oh, thank you. It was fun.
Thank you also to Christopher for producing and co-hosting. And of course, thank you for listening. We do like our listeners. If you'd like to say hello or send us robots, do hit the contact link on Embedded FM. Our email, alternatively, is show@embeddedfm. Although that contact link is safer, so do that if you can. I do have a final thought. This one from Norman Rockwell. Isn't that sort of weird? And he says, the secret to so many artists living so long is that every painting is a new adventure. So you see, they're always looking ahead to something new and exciting. The secret is not to look back.
It didn't work for Mozart.